So we're going to do another kinematics problem. This time we're looking, it's again an MIT exam problem, and it says a rock is thrown downward from a bridge at an initial speed of 10 meters per second at an angle 39.9 degrees from the vertical as shown. At the same instant, a boat is passing under the bridge traveling 6 meters per second in the direction shown. See the note formula about trig values that was given, that's this. Find the vertical and horizontal components of the initial velocity of the rock as seen by the person on the bridge. Clearly indicate you're drawing your choices of axes. So first thing I'm going to do is I'm going to do exactly that. So I'll let the ball on top of the bridge be my origin. And I'll let up be positive. I'm going to let to the right be positive. Why? Because this boat is moving to the right, and we're just calling that 6 meters per second. So I'm going to call that positive. Okay, so let's examine this triangle here. We have our velocity in the y direction, which is going to be equal to what? Our velocity times cosine of our angle, which is 10 times, so cosine of 36.9, that's just right here, that's 0.8. 0.80, or just 8 meters per second. Likewise, you could come over here and say velocity in the x direction is equal to v naught sine of the angle. I don't have the room to put it, but I'll just move it over here. Or velocity in the x direction is 10 times sine of that angle is 0.60. Or velocity in the x direction is just 6 meters per second. So the vertical component of velocity, according to the guy standing on the bridge, is 8 meters per second. And the horizontal component of velocity, again according to the guy standing on the bridge, is 6 meters per second. So this is part A. Part B says find the vertical and horizontal components of the initial velocity of the rock as seen by the person in the boat. So the person in the boat, he's already moving in the x direction. It's the only place he's moving. So vertically, so orange is for the guy in the boat. The vertical component doesn't change. And I should say this is minus 8 meters per second because we let up be positive. So the vertical component of velocity is still equal to minus 8 meters per second. Now what's going to change is the horizontal. And I guess the best way to think about this is a little bit of a classic relativity, is imagine you're in a car and you're going 20 miles per hour down the road. And the car next to you is also going 20 miles per hour. Well, from your perspective, it looks like the car is not really moving. It stays just as far behind you as it always does. Well, this is basically what's happening here. The ball, or the rock, is moving at the same speed horizontally as the boat. So because of that, it looks stationary. So it doesn't look like it's moving at all in the horizontal component, in the horizontal direction. I'm sorry. So yeah, that was part B. That was part of part B. Yeah, that was it. Okay, sorry. So how it's related to the rock as it's moving from the bridge. So that was the velocity of the rock appears to be moving as seen from the bridge. Okay, no, we just did B. So now we're on C. Sorry about that, I got confused. So now we just need to draw vector diagrams showing how the velocity appears to be moving as seen from the bridge. Well, according to the bridge, it's got some in the x direction, some in the y direction, and ultimately has this 10 meters per second velocity. So that is for this first bit. As seen by the person in the boat just sees this, which is minus 8 meters per second. And I guess I'll just use black again. And the velocity of the boat with respect to the bridge. Well, the bridge isn't moving. So he's just going to watch the boat move at 6 meters per second. Because you're just standing on the bridge and you're watching the boat move. So that is our little vector drawing. We looked at the velocity and compared it from these different perspectives. Really good problem if you ever need to take Intro to Modern Physics. I think this is a really good topic to cover. So hopefully